welcome to today's video. We are studying organic chemistry, a break from physics, and remember, we are always and the hundreds. So firstly, we'll be covering hydrocarbons. So let's see, hydrocarbons, they contain only hydrogen and carbon. They're compounds containing only hydrogen and carbon. Now we look at the three types of formula. So we have disparate formulae, and then we have a structural formula, and at last we have a molecular formula. So let's say we are drawing C5H12. So our disparate formula would look like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. And the structural formula, so we see that over here one C is bonded to 3, so it will be CH3, and over here CH2, 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 and again a CH3. Here is a structural formula, a disparate formula, and a molecular formula. So we can derive a molecular formula from a disparate formula and the structural formula. So to derive it, we just count 1, 2, 3, 4, 5 carbons. So we get C5, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen. That's how we get a H12. Now let's talk about fuels. There are three main types of fuels over here. We have natural gas, we have petroleum, and we have coal. So petroleum is formed from dead organisms at the bottom of the ocean floor, and it is buried under thick sediments. High pressures convert them to petroleum. Now methane, it is a main constituent of natural gas. It is often found with petroleum, and it is formed in the same way, except high temperature and pressure cause the compounds to break down to gas. Meanwhile, coal is the remains of lush vegetation that grew in the swamps. Now we look at the refining of petroleum. So we label all our fractions. The first fraction is refinery gas. Its use for gas in heating and cooking. And then we have gasoline, which is used for fuel in cars. Thirdly, we have naphtha. It is used as chemical feedstock according to the syllabus guide. The fourth fraction is kerosene, which is used for jet fuel. The fifth fraction is diesel oil, which is used for fuel in diesel engines. A sixth fraction is fuel oil, which is used for fuel in ships and home heating systems. A seventh fraction is lubricating oil. It's used for lubricants, waxes, and polishes. And the final eighth fraction is bitumen, which is used for making roads. So as we go down, the trends shown are 1. Chain length, boiling points, and viscosity increase as we go down. And secondly, volatility and flammability decrease as we go down. You can take a screenshot of this. Now we move on to homologous series. So there are 4 homologous series. We have the alkenes, alkanes. Let's start with the alkanes. We have the alkanes, alkenes, alcohols, and carboxylic acids. Okay, so homologous series is a family of similar compounds. Write that down. A family of similar compounds that have the same functional group and same chemical properties. This is a very important definition, you must know. And then we have something known as functional group, which is an atom or a group of atoms in a molecule that determine how they will react. So for example, the functional group of alcohols is the OH group. And for carboxylic acids, it is the COOH group. And in the homologous series, we have a few properties we must remember. So first thing is all compounds fit same general formula. Second is chain length increases by 1 CH2 unit at a time. The third thing is compounds show trend in physical properties due to the chain length. Now we look at naming of compounds. So we have seen these prefixes, like we have seen methane, ethane, propane, butane and pentane. What do these exactly mean? So meth means one carbon atom. One example is methane, which is CH4. Let's take example of alkanes over here since they're easier to understand. Then we have eth, which means two carbon atoms. One example is ethane, which is C2H6. Then we have propane, which means three carbon atoms. So propane, C3H8. And then we have bute, and one example that means four carbon atoms. And one example is butane, which is C4H10. Then this is not in syllabus really, but we have pent. Pent means 5 carbon atoms, and we have pentane, which is C5H12. And then we have suffixes. So we have
Okay, I found this on the web for 5
Oops.
and then we have a suffix.
Siri heard that. I'm so sorry. Okay, so we have suffixes. We have ane, ene, ol, and oic acid. So one example. So these tell us about the homologous series they belong to. For example, ane belongs to alkane. So remember ane, alk, ane. And then ene belongs to alkene. Remember ene, alk, ene. And then ol, which means it belongs to alcohol. Remember alcohol. And then oic acid, which means it belongs to carboxylic acid. Remember carboxylic acid. There's no Yeah, we remember it that way. Okay. Now we move to the alkanes, our first homologous series. So the first property of them is that they occur naturally in petroleum. They are hydrocarbons containing only hydrogen and carbon. They are saturated. Saturated in the sense they have carbon-carbon single bonds only. And the general formula is CnH2n. So basically your general formula is a formula used for all members of that homologous series. So let's say we have the alkanes. So our general formula is CnH2n plus 2. Now let's take an example of methane. So over here, meth means 1, so we have 1 carbon atom, so n equals to 1, and then 2n plus 2. So 2n will be 2 and plus 2, which gives us CH4. Alright. Then we look at the chemical properties of alkanes. By the way, I'll just name the first 4 alkanes for you, which is methane, ethane, propane, and butane. Then we look at the chemical properties of alkanes. So firstly, they are saturated, they are unreactive, they are quite unreactive except for one of the reactions which we are going to cover further. And the shorter chain alkanes are used as fuel. Because they burn well in a good supply of oxygen, these are used as fuel. So, an example of complete combustion will be CH4 plus 2O2 equal to CO2 plus 2H2O plus heat energy. So remember, whenever there is complete combustion, there will always be carbon dioxide produced. So remember, complete carbon dioxide. However, once we look at incomplete combustion, this is one example. So CH4 or methane plus 3O2 gives us 2CO, carbon monoxide, is 4H2O plus lesser heat energy. So remember, incomplete and carbon monoxide. This is a good trick to use. Whenever you see carbon monoxide in a combustion reaction, just consider it an incomplete combustion. Alright. Now we move on to the reactions of alkenes. So alkenes react in chlorine in presence of ultraviolet light. So UV light is used as a catalyst. It provides activation energy. And this reaction is known as photochemical substitution. This is how the reaction looks like. We have a methane We have a chlorine. In presence of UV light, it gives us chloromethane. And hydrochloric acid. Now we look at structural isomers. So structural isomers are compounds with same molecular formula but different structural formula. So let's look at butane. Alright, we have our butane over here, which is C4H10. And its boiling point is 0 degrees Celsius. Now we can rearrange this, because why not? We just want to rearrange it. The chemist wanted to rearrange it. So we'll just rearrange it to make it 2-methyl propane. So it will look somewhat like this. This is the alkyl group. This group over here is the alkyl group. And its boiling point will be minus 10 degrees Celsius. Because of different structural formula, they have different boiling points. 2-methyl propane is a bit more volatile than butane. Now we look at a very important reaction, which is cracking alkanes to form alkenes, the second homologous series. So cracking means breaking molecules into smaller ones, and we use zeolite catalyst for catalytic cracking. A very important example is cracking of decane. These questions come a lot in exam. We'll just look at cracking of decane. So C10H22 is a decane. So the possible products which can be formed is C5H12, which is pentane, C3H6, which is propene, and C2H4, which is ethene. Or it can also be this way. This is a decane. It forms C6H14, which is hexane, and 2C2H4, which is ethene. So basically a trick for this is that we have to make sure that all of these carbons and all of these hydrogens are used up. So in this example we have C10. So 5 over here, 5 plus 3, 8 over here, and 8 plus 2, 10. So 10 carbons are used up. And over here we have H22. So 12 over here, 12 plus 6, 18 over here, 18 plus 4, 22. So all the hydrogens are used up. Now we look at this example. So we have C10, so 6 and 2 C2, so 4. That means carbons are used up. Then we look at S22, so 14 plus 8, because we have 2 C2H4. 14 plus 8 is 22, so that means all our hydrogens are used up. So this is a trick for doing this. For cracking these questions, if I say it literally, you may screenshot this. Now we move on to alkenes. So alkenes are hydrocarbons as well. Their general formula, the GF over here is general formula, not girlfriend, is CnH2n, and the CC bond is the functional group. So you notice this is C double bonded, right? That means this is unsaturated. Now we'll name the first 4 alkenes using the table. So we cannot have a methene. There cannot be methene, since methene would just be CH2. And CH2 is basically a chain. So we cannot have methene. Bye bye methene. We are not even existent right now. So we have ethene, propene, butene. We'll come to butene and propene since they have isomers. So for now we just took to protein and butene. Propene and butene. My bad girl. So we have ethene, which is C2H4, propene, which is C3H6, using this general formula. Butene, which is C4H8. These are the molecular formulas of it. And some of the key pointers is that they do not occur naturally. In petroleum. They are made by cracking. Second is that they are more reactive than alkanes. Because that double bond, the CC double bond, can break to add on atoms. Now the word add on is very important, because this means that this has addition reactions. And that means addition reaction, only one product is formed. Oops. Okay, so we have these two reactions to remember. Now let's take ethene. So first reaction to remember, C2H4 gas. We'll include state symbols today because we love our state. Come on. State is a part of an identity. So C2H4 gas plus H2 gas. I'll just write that down because I just noticed we didn't have enough space here. So C2H4 gas plus H2 gas, heat, pressure, nickel as a catalyst. We have C2H6, which is also a gas. And this is ethene. This is ethane. So it can add on hydrogen to form ethane. Secondly, we have C2H4, which is ethene plus H2O, which is water vapor, or you can know it as steam. We'll get to the conditions of this reaction later. So for now we just said heat, pressure and acid catalyst, which forms C2H5OH, which is a liquid, and this is ethanol, part of the alcohol homologous series. Now we look for the test for unsaturation. Okay, so test for unsaturation. Hold up, I just need to exit this and come back. So we do this using bromine water. Honestly, bromine is so notorious because it is either red, it is either orange or brown, and even yellow sometimes in the marking scheme. I will never get the color. So for now we just take it as orange because that's the safest option to go for. So we have our ethene, which is a gas, plus bromine water, that is Br2. Note that this is colorless and this is orange. This forms 1,2-dibromoethane. We say it is 1,2 because there is a bromine atom here and there is one here. So it's on the first and second position. So that's why 1,2-dibromoethane, which is a liquid. And now we look at the structural isomers. So one example, let's take but1ene. but2ene. So you notice the number over here, right? 2 and 1. That means the functional group is at that position. Let me explain. So we have but1ene. So over here the functional group or CC double bond is at the first position. So if we count from here, we have to count from the lowest value. So 1, 2, 3, 4. You can either count it this way, you can draw it this way. So over here it is on the first position as well, if you count from the left to right. So you basically have to count to the lowest value. So in but2ene, now let's look at but2ene. It can either be like this, it will be like this, because 1, 2, 1, 2. So from either side it is on the second carbon atom. But now let's stop here. Continuing in part 2.